Um, so I was thinking today we would talk more about domain, range, and level curves. There was something else on my mind, but I don't know what it was now. There's other things you can think of that I should be thinking of, just let me know, but let's start there. Like with this question, find the domain of this function f of xy equal to the square root of 2x minus y, and graph it. That's not a very good direction. So when I said graph it, you might have thought I meant graph the function, but I actually meant graph the domain. So apologies if that was confusing. But let's go ahead and talk about finding the domain. So I'm going to find the domain. I'm using my regular domain rules. So like, for example, just as a quick aside, if my function was instead like a 17a function where we had f of x equal to the square root of like x plus 3, the way I would find the domain of that would be setting x plus 3 to be greater than or equal to 0. And then I would get x greater than or equal to -3. I suppose if I wanted to graph it, I could graph it on the number line. And my graph, although not very exciting, that's 0 and that's -3. My graph is everything to the right of -3, including -3. That's how I find the domain of like a regular function in 17a, or a function of one variable. But now, excuse me, we're dealing with functions of two variables. So our domain is not just a line on the number line, it's a region in the two-dimensional Cartesian plane. So what we're going to do is still the same sort of idea. We're still going to take our inside the square root thing and say, well, I still can't take a square root of a negative number. So I have to say that 2x minus y is greater than or equal to 0. And typically at this juncture for functions of two variables, one of two things is going to happen. You're either going to be able to nicely isolate y, welcome on in, which we're going to be able to do here. We can totally get y by itself, or you're probably going to see like an x squared plus y squared. Those are kind of the two flavors of domain questions that we most often see. You can see other things, but most of the time, you can either isolate y or isolate x squared plus y squared. That's pretty typical. Here, I can isolate y. The easiest way to do this would just be to add y to both sides and say 2x is greater than or equal to y, or if you prefer, y is less than or equal to 2x. So that's what my domain is. And there's not really a lovely way to write the domain. Here's the attendance form again for those of you on Zoom. You could either write the domain using set notation. You say my domain is the set of all coordinates x comma y such that y is less than or equal to 2x. It doesn't feel very like great though. You're kind of just saying the same thing you said. But then the other, well, in fact, usually like in a web work kind of homework problem, usually they'll have you describe the domain as all the points that satisfy some criteria. So some options might be like the entire real number line, or sorry, the entire real plane, or everything inside the circle or outside the circle, or everything inside the circle including the circle, or everything above a line and below a line. Like there's lots of options they're usually giving you when you have to answer this kind of domain question. So here, we're just going to graph it. And the way we're going to graph it is by graphing the line or the curve where you would have an equality. So what we're going to do is we're going to graph y equal to 2x. And here's what I would say. When you're doing this sort of graphing of the domain thing, if it's an inequality that has an equal, so if like it's the less than or equal to or bigger than or equal to, draw it so it's a solid curve. Whereas if it's a strictly greater than, or we'll do the next example, we'll do a strictly greater than often, you want to draw it dashed. Because the idea is you want to include the boundary when it's equals, and you want to not include it when it's not equal. So the dashed line indicates not included. So I'll say it again in a minute. But here, I'm just going to draw the line y equals 2x. Running out of room. And I'm going to draw it solid. So there's y equals 2x. Okay, I want my domain to be every point in the plane so that y is less than or equal to 2x. Here's what almost always happens. The line we've drawn, whether it's a straight line, a curve, a circle, whatever, that thing is a boundary. And it's the boundary that separates the stuff that's in the domain from the stuff that's not in the domain. So all we have to do is pick one point on either side, not on the line. Like you shouldn't pick the origin. I'm going to pick the point 0, 3. I'm going to ask myself, okay, is 0, 3 in the domain? Does it satisfy this inequality? So if y is 3 and x is 0, is 3 less than or equal to 0? It's not. Right? It's definitely not. So that point, not in the domain. This whole entire side of the xy plane is not in the domain. It's the other side. It's all of this. That's our domain. So here our domain you could describe as everything under the line y equals 2x, I guess is what we do. Or on one side of the line y. Oh, sure. I didn't even know that was an option. Yes. Hopefully it goes well. Someone requested live transcription of my Zoom, which I didn't. I mean, I should know that's an option. I've definitely seen it in multiple meetings, but hopefully the live transcription is. Oh, that's a little distracting. Can I make that not show up for me? Okay, can you hide? Just hide. Nope, it doesn't want to hide. Okay. Well, I'll just have to ignore it as best I can. All right. So, well, we're not quite done with this problem, but questions so far about what we've done here. Okay, one other thing I want to say about it, which is often when we talk about domain, we'll talk about the range. So what is the range of this? Well, I have enough to look there, I suppose. Range is always a little dicey. It kind of just, oops, no, let's do it right. It mostly involves looking at what you've got and trying to just kind of ask yourself, how big can it get? How small? So if I'm looking at my function equal to the square root of 2x minus y, how small can it get? What's the smallest output we can get when we're taking the square root of something? Definitely. Yeah. I heard someone like whisper, it's 0. The smallest you can get is 0. If you plug it, I mean, there's a lot of ways you can get 0. You really, in fact, any point on this line would give you 0. So 0, 0, or 1, 2, 2, 4, or 3.2, 6.4, right? There's lots of ways we can get 0. So the smallest output would be that the function f of xy is equal to 0. What about the biggest that you get? Well, biggest is hard, not hard to answer, but requires a little thought. Typically what I do for kind of both directions is if I'm not sure what it is, I kind of set one thing equal to a number. So I'm going to say, let's let y equal 0. If y equals 0, I'm left with the square root of 2x. And if x can get super, 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 super big, then the output can also. So I think about setting one thing kind of constant and then letting the other thing range over its domain. So here I can see the biggest it can get, well, there's no bound. We can go all the way up to infinity. So our range here is 0 inclusive to infinity. Always exclusive, right? Because infinity is not really a number. Yeah. So, well, yes, but that's because it's already hidden. So what I'm really saying here is that, for example, we could say you're getting a 0 output with a lot of different possible inputs. One possible input would be, for example, f of 3, 6. If I plug in 3 for x and 6 for y, I'm getting the square root of 2 times 3 minus 6, which is the square root of 0, which is 0. So that's my smallest possible range for this function. Or I should say the lowest value in my range. So interestingly, the domain is a whole like area in 2 dimensions, whereas the range is still kind of your typical number line kind of thing, where it's just an interval on the number line. And that makes some sense because your domain is talking about what X and Y can do, whereas your range is talking about what the outputs, which are we think of as the Z's, can be. So there's some sense there about what's going on. Let's look at a couple other examples. Again, please don't hesitate to ask questions if you have them. Let's look at this next one. Let's say, kind of promised that. Sure, let's do that. Let's say we have xy equal to, sure, let's go 10 over the square root of, yeah, why not? 25 minus x squared minus y squared. This is a very kind of classic example in this class of a domain and range question. And the thing I would say we want to first kind of take note of is, even though it's not written exactly like it, I see x squared plus y squared. I mean, really, I see minus x squared minus y squared, but we could factor out the minus and get minus parentheses x squared plus y squared. So we are thinking I'm probably going to get an x squared plus y squared showing up somehow. All right, so here for our domain, again, the usual rules apply. We don't want to take a square root of a negative. We don't want to be dividing by 0. So here what we need to say is that the stuff inside the square root that also happens to be in the denominator had better be strictly greater than 0 and not equal to 0. Like, so if it was equal to 0, you can take the square root of 0. What's the square root of 0? 0, which is fine, except then we would be dividing by 0. So that's why it's not fine. All right. In this kind of situation, we don't want to solve for 1. Right? In the previous one, totally like had 2x minus y greater than equal to 0, and then isolated 1. Not what we want to do here. If you see an x squared plus y squared, you want that by itself. So I'm going to rewrite this as negative x squared minus y squared is bigger than negative 25, and then multiply both sides by negative 1 to get x squared plus y squared is less than positive 25. That's my domain. And again, I think without the graph, it's not very meaningful. I mean, sure, I can think of some values of x and y that make that work. Here are some points in my domain. Just for example, off the top of my head, 1, 2, negative 3, 1, 4, negative 3. Oh, nope, that's not in there. That's too big. A little too big. But 4, negative 2. Right, all of those points satisfy this inequality. On the other hand, there are lots of points not in the domain, like 4, negative 3, or 10, 0, et cetera, et cetera, et cetera. I could go on, right? I mean, literally, we could go on forever. But what we really want to do is we want to graph this thing. So what we're going to graph is not the inequality right after that. We're going to graph just the equation. So we're going to graph x squared plus y squared equal to 25. Now here's why these kinds of ones come up often. Their graphs are very familiar to us. X squared plus y squared equals 25 is a circle, centered at the origin, radius of 5. For this one, since it's a strict inequality, I don't want it to equal 25, I'm going to end up drawing my circle with a dashed outline so that it looks like I'm not including it. So that's how we don't include the border. Let's see how good my drawing skills are. Mediocre, but fine. So like this point here is the point 5, 0, 0, 5, et cetera, et cetera, et cetera. So there's the border of my domain, which I do not want to include that border. And I want everything on one side of it. You always get one side, you always exclude the other side. Which side do I want? The inside or the outside? We can always tell by testing a point. So test the point that you know is on the inside. Any point that's on the inside of that circle. There's an obvious, easy choice. Right, test 0, 0. Does 0, 0 make this statement true? Is 0 squared plus 0 squared less than 25? Yeah, so if we test 0, 0, and we ask, is 0 squared plus 0 squared less than 25? The answer is yes, which means that point, so 0, 0, and everything that happens to be on the same side of the border as 0, 0 is in your domain. Oops. So once you know one point, you know that everything on that side is where your domain lives. And everything on the other side is not. So all this stuff out here is not in the domain. And the way I would describe this domain using the words of web work is my domain is everything inside of a circle, excluding the boundary of the circle, or however they say it. I'm not exactly sure what word. Question?
Is there a way to write this in interval notation?
There isn't a great way to write it in interval notation. The best way to write this is using what's called set or set builder notation. So the way we could write the domain is the set containing all coordinates x comma y such that x squared plus y squared is less than 25. It feels a little disappointing because you're kind of just rewriting the inequality that you already have. But yeah, sadly, there really is no interval notation because it's not an interval. Right? An interval is just something that's like from left to right. But we have way more than left to right. We also have up and down. So yeah, we're kind of stuck with saying it's all these coordinates that meet this criteria. I wish we could write it in interval notation because it would feel more satisfying. Do they leave enough room to write about the range? Maybe, maybe not. So let's just use another piece of paper. So what about the range of this function? So when I think about the range of a function, again, I'm trying to think about how big it can be and how small it can be. So when I have fractions or rational expressions, right, when I have denominators, I'm kind of thinking the following. So I know that the fraction is going to be small when the denominator is large. And vice versa. Fraction is going to be large when the denominator is small. And the reason I'm thinking about this is because I see for this particular expression, my denominator is the thing that's variable. And my numerator is just 10. But my denominator can be kind of, well, it can get large or small. So let's ask this. For values of x and y that are in our domain, all right, there's a domain up there. What's the biggest this can be? How big can that get? Well, I'm subtracting off x squared and y squared. So if I pick numbers for x and y, it's just going to get smaller. Right? Like if x is 1 and y is 2, I mean, 21, 5, minus 1, minus 4, which is smaller than it started off. So what are the things I could pick for x and y that would make it essentially the biggest it could be? Well, what's going to have me subtracting off of these? It's a small number and a not big number. Small number and a small number. What are the smallest numbers? Not a good question, but I think you know what I mean. 0, right? If you're not worried about like technically the smallest number is like negative, a bajillion, right? Whatever. But if we're talking about small and absolute value, we're meaning 0. And if x is 0 and y is 0, that inside is still going to be as big as possible because you're taking away the least amount you can. Right? 0 squared is 0, 0 squared is 0. So if x and y are both 0, you're going to get the square root of 25 minus 0 minus 0, which is just 5. That's the biggest that can be. right? There's no, right, because if you pick x to be negative, a negative number squared is still positive. Same deal for y. On the other side of things, we know from our previous problem that that the smallest a square root can ever give you is a 0. That there's no way you can get a negative number out of a square root. Square root of 9 is 3. It's not negative 3. So I know that if I pick, for example, x equal to 5 and y equal to 0, I can totally get 0 here. Well, but technically I don't want 0. It's okay, we're gonna work with it. But then I have this fraction, right? I don't actually just have the square root of 25 minus x squared minus y squared. I have 10 divided by that. So I really don't want this to be able to equal 0, right? And why do I get to say that I don't really have that? Well, let's look back at our domain. All right. Our domain said the inside stuff actually had to be not 0. So it's okay that the inside stuff is not actually 0 here. We're getting rid of it because we never really had it to start with. Why am I worried about that? Because what I'm going to do is I'm going to kind of flip things over. I'm going to say that 1 over this is bigger than or equal to 1 over 5 and is less than the quote unquote reciprocal of 0. If I'm off page, let me know. So that's where we're at. We're at saying, oh, if this thing is between 0 and 5, then its reciprocal is, well, if I'm smaller than 5, my reciprocal is bigger than 1/5. Let's think about that. What's the number smaller than 5? 4. What's the reciprocal of 4? 1/4, which is bigger than 1/5. Right? A quarter is bigger than a fifth. Or you could even go super small, right? Like what if my number was 1/1000? Well, that's definitely smaller than 5. And its reciprocal is, and that's definitely way bigger than 1/5. So when you take reciprocals of things, it changes the direction of the inequality. And then certainly, if I'm picking numbers that are closer and closer and closer and closer to 0, their reciprocals are getting larger and larger and larger and larger. They're getting infinitely large. Lastly, still need a 10. So multiply everything by 10. So there's our range for this function. The range goes as low as 2, as high as you want. Range is kind of funky. Question. Oh, what did I just do in this last step? Which I didn't say very explicitly, but I did do it. So I had, right, I had 1 over the square root of 25 minus x squared minus y squared, and I wanted 10. So I multiplied everything by 10. Infinity times 10, still infinity. Yeah, so we're just multiplying everything by 10. No problem. This is not the only way to get there. Like some people would probably just look at the original function and be like, well, I can make this as big as possible and make the denominator small. X and y are both 0. 10 over the square root of 25 is 10 to 5, which is 2. And then the bigger x and y get, the smaller the denominator gets, so the larger the fraction gets. But that's not really how my can be, so one more time. So let's take a look. That's an excellent question. Why can't they make this bigger than 5? So I have the square root of 25 minus x squared minus y squared. Or as it might help to write it, the square root of 25 minus x squared plus y squared. And what I would encourage all of you to take to heart is that x squared plus y squared is always non-negative. Doesn't matter what you pick. X could be negative a billion, Y could be positive 2. You square them both, they both become positive, and then you add them together, it's still positive. Or at the very least, they're both 0. You square them, you still get 0. 0 plus 0 is still 0. So this has to always be greater than or equal to 0, which means if you subtract it, you're subtracting off something positive. So it is definitely the case that 25 minus something that is non-negative, well, that has to be less than or equal to 25 minus 0, which is 25. There's no way, right, no matter what you pick for x and y, that this expression here, it couldn't ever be larger than 25. Unless you're using imaginary numbers, which we're not. And then we can take the square root of everything. So the square root of this is definitely less than or equal to the square root of that, which is 5. Excuse me. Let's look at a similar example, because I think this actually is similar. This function all on its own is similar to a homework question you all have. Let's say that we wanted to, yeah, I kind of want to change it, but I guess I won't. Let's say we have this function of xy equal to the square root of 49 minus x squared minus y squared. I was going to do some level curves. All right, I will do some level curves here. So, square root of 49 minus x squared minus y squared. Same flavor, right? This is very, very similar to what we just did. So, if I'm thinking starting domain, I'm starting with my usual square root issue, which is that the inside of the argument of the square root had better be greater than or equal to 0. She's going to leave me with, I'm going to bring it over to the right and say 49 is bigger than or equal to x squared plus y squared. Or if you prefer to have your variables on the left, because I know a lot of us do, x squared plus y squared is less than or equal to 49. I'm going to do the graphing. I'm going to graph x squared plus y squared equal to 49, which is a circle, center of the origin, radius is 7. And I am going to draw it solidly this time because I do want to include that boundary. I want the points where this is equal to 0, as my inequality says. Label a couple points just for fun. Okay. And oh, do I want what do I want? The outside to the inside. It's not always going to be the inside. What I would say is you need to check every time, because someone might another day give you this question instead. They might say g of xy equals the square root of x squared plus y squared minus 49. And that's going to have the outside domain, whereas this one definitely has the inside domain. If I test 0, 0 again, it definitely satisfies this inequality. So everything on the inside. There's my domain. The range here which we'll also see when we graph this function, looks like the following. Well, what's the smallest we can get? That's going to be the biggest we can get. It's all right. Yeah, the smallest we can get is 0. So, right, the smallest output is going to be f of, there's lots of different ways you can get there. I'm going to make up one of them. F of 7 comma 0. That's going to be the square root of 49 minus 0, which is 0. That's the smallest thing I can get. I can't get any smaller than that because if I put in numbers that make the inside less, I mean, it's the square root of a negative. So I'm stuck. That's as small as I get. There's lots of different ways to get them. Really, I should say, any point on this boundary of my domain as an input would give me that output. So in fact, this boundary here is a level curve, right? That circle of radius 7 is the circle of radius 7 that would be the level curve where z or c equals 0. That's what the output value is. Well, we're going to graph it in a second. So like, on the other hand, what's the largest? Well, someone already said it. What's the largest output we can get? Yeah, definitely 7. And you can only get that by plugging in 0 for x and 0 for y. F of 0, 0 is the square root of 49 minus 0 squared minus 0 squared, which is definitely 7. I didn't even draw this. We could also, and we should also probably mention level curves. So level curves the long way are setting your function equal to whatever list of different values you want. Values that have to be in the range. So there's a couple questions on your homework that say like, what's the range? And then later on, like what values can C be where C is a level curve? And the answer is the same as the range. Because you can only pick level curve values for things that are possible outputs. Like I couldn't pick C equal to 8 because there's no way that this function can actually equal 8. So I'm going to pick level curves like C equal to 7, or 6, or 5. I'm going to be very basic about it and just pick nice integers. But I'm only picking integers that are in my range, I'm not picking anything else. Now, I really don't want to do this. What I mean is I don't want to do the same work 7 or 8 times. I don't want to set my function equal to 7 and then solve for it so it looks familiar, or set it equal to 6 and then solve for it so it looks familiar. What the usual practice is here is say I'm going to set my function equal to C. And then I'm going to try to make it look like something that looks familiar to me. So either, just like when you were finding the domain of the previous one, you're either going to solve for y, if that makes sense, or you're going to solve for x squared plus y squared. Those are the really, like with very rare exception, those are the only two things you really want to try and get by themselves. You want y equals some stuff, or you want x squared plus y squared equals some stuff. Kind of. So here I see an x squared plus y squared. That's what I'm going for. So I'm going to square both sides. And then I'm going to bring the x squared plus y squared to the left. So x squared plus y squared, and we'll subtract c squared on the right. So this is what kind of graph? I have x squared plus y squared equal to a number. Everyone's like second or third favorite shape. Circle. That's why it's really, it comes up like you can't like graph a square nicely or rectangle nicely, like at least make an equation nicely. But it's very easy to write the equation of the circle, which is probably why it's a common example. It comes up a lot. So when we see x squared plus y squared equal to a number, oh, that's a circle. The center is the origin. And the radius is, well, it depends on how high up we are. But the radius is going to be the square root of 49 minus c squared. So we're going to draw some level curves, which they thought I brought my pen. Now I feel like I forgot it. Level curve thing, sorry. So I've got a couple of different colors. We can alternate. So I'm going to try and cherry pick some values here, but not really. So if c equals 0, my radius is going to be the square root of 49. If c equals 1, my radius is going to be the square root of 48. C equals 2, square root of 45. Okay, I think we get the picture. C equals 3, square root of 40. I'm not going to draw all those. C equals 4. R is going to be the square root of 49 minus 16 is 33. You pick 5, you get the square root of 49 minus 25 is 24. And C equals 6. R is going to be the square root of 49 minus 36, which is. And I don't really want to do C equals 7. I mean, I could, but here's what you get. C equals 7, your radius is the square root of 0. And the circle with radius 0 is just the point. So that'll be the top of the thing, right? Because that's the highest level, right? C equals 7, we've gone all the way up to the highest height we can get. Okay. So I'm just going to do a few of these. Let's do this one and sure, this one. And actually, these three. So let's see here. C equals 0. Try to be a little bit precise here. So here's my level curve for C equals 0. So on the XY plane, right, on the floor, C equals 0, my circle, my level curve is the circle of radius. And then I go up to say a height of 4. And now my radius is the square root of 33, which is a little less than 6. Right, square root of 36 is 6, or 33 is a little bit less. So up here, 4 up, here's my new level curve. C equals square root of 33. I'm sorry, C equals 4. I made that mistake. So we're 4 high, and our, sorry, I know that looks terrible. Let me just cross it out. Right then. C equals 4. So we've gone up to a height of 4, and our circle got a little bit smaller. And now we're going to go up to a height of 5, and our circle is going to be having a radius of slightly less than 5. Right, square root of 24 is a little bit less than square root of 25. So here's our next circle. I know, it's terrible. So there's our circle. Height 5, radius slightly less than 5. We'll do one more. Our circle of height 6 has a radius of a little bit less than 4. The square root of 13 is less than square root of 13. So right here. And again, I know my drawings are just okay. C equals 6. So as we go higher and higher and higher and higher, our circles get smaller and smaller and smaller and smaller. And I would say, if you're trying to describe what the level curves look like in web work, we have concentric circles that are unevenly spaced. And the way you can see that they're unevenly spaced is that if you increase your height by the same interval each time, if your spacing doesn't increase at the same interval, then you know that they're uneven. And these are definitely not increasing at the same interval or decreasing at the same interval. These all increase by 1, here to here, here to here, here to here, right? Those are definitely different amounts. I don't know what they are exactly, but I know they're not the same. I know that 7 minus the square root of 48 is not the same as the square root of 48 minus the square root of 45, and so on and so on and so forth. So these are definitely unequally spaced. I know my drawing might make them look like they are equally spaced. That's also because I cherry-picked the numbers here, but they're definitely not equally spaced out. So let's see what the graph looks like the surface in 3 dimensions. So here's what we've got. We've essentially got this bottom circle here. And then we've got smaller and smaller circles as we go up. So, right, if I try and draw a few of them here, and here's like one of my level curves, another level curve. That's kind of the idea, is that these level curves here are corresponding to those curves on your surface there. I know I didn't say it, but this graph actually is a hemisphere, right? The top half of a sphere. Not that we need to necessarily know that, but that is what it is. I don't think anyone's really asking us that. There was something else. Oh, I know what it was. Question.
So the inside is more the top part of the.
In this example, yes. But what I would say more generally is we have to look at how it's labeled, right? So like if you look at a topographical map, it depends on what numbers are on it. So here I know that the inside is higher up because of, and again, I know my writing is not best, because the higher numbers are further in. C equals 6 is the innermost circle. C equals 5 is a little further out. C equals 4 is even a little further out. C equals 0 is even further out. So the lower values for literally just lower elevations are the bigger circles, and the higher values smaller, higher, smaller, higher, smaller. That's what's going on here. For contrast, yeah, let's contrast. If we wanted to look at, say, the function f of xy equal to x squared plus y squared, and draw some level curves, well, let's look at some prime choices here. Let's say we want to pick c equal to, let's just say c equal to c for a second. We'll carry on this thing. Our level curves also going to be circles. We're going to set x squared plus y squared equal to c. So our level curves here are also circles, right? There's a lot of circles when you deal with, like, not always circles, but a lot of times you get circles. Level curves here are circles. And what's their radius? Square root of c, right? The equation of a circle is, well, x minus the center squared plus y minus the center coordinate squared equal to the radius squared. So radius here has to be the square root of c, because that's square root of c squared. So if we pick some choice values of c, like c equal to 1, or 4, or 9, or 16, picking the nice square values, we see that we get circles of radius 1, 2, 3, and 4. So if we're going to try and draw the level curves here, try and do a good job. Alternate some colors here. So here's the level curve for c equal to 1. Here's the level curve for c equal to 2. Sorry, c equal to 4. Oh, man. Here's the level curve for c equal to 9. And finally, here's the level curve for c equal to 16. So here, as we go higher up, our circles get bigger. So what we are kind of getting is something that looks more like this. It's a paraboloid. And our circles are definitely not equally spaced apart, because every time our radius gets 1 larger, we're going up by not the same amount, right? From here to here, the radius is 1 larger, and we went up by 3. From here to here, the radius is 1 larger, went up by 5, and then by 7, and so on. Yeah. Well, so the reason is, I mean, there's a couple reasons. It's because of what kind of function it is. But here, the idea essentially is, as the x and y values get larger, so further away from the origin, right? Because x gets bigger that way and that way, y gets bigger that way. As we move away from the origin, our output's larger, meaning higher up. Whereas in the previous one, as we moved away from the origin, right? The origin here was the biggest value we got. When you plugged in 0, 0 for x and y, you got the biggest possible output. And then as you moved away from the origin, you ended up getting lesser and lesser values because they made the insides not as big. But we can also, but really what I want to stress here is that the level curves tell us this. The level curves tell us that, and okay, I'm going to try my best here. Okay, so here's my x, y, z coordinate system. And what we're saying here is that, all right, I went up to a height of 1, and I got that level curve. And then I went up to a height of 4. And I got that level curve. And I went up to a height of 9. and got that level curve. That's the correspondence, right? That circle is literally the same as that circle. That circle is the same as that circle. That circle is the same as that circle. And the C value is really just telling you how high up they are in the Z direction. There's something else worth saying here. Maybe not. Other questions? Oh, I know what I was going to say. Other questions. Okay. What's the domain? Well, is there anything that's not in the domain? Oh, sorry, you can't see the function. There's the function. We have no problems. Oh, questions, comment, answer.
When you talk about domain, I know this is my like three-dimensional, it's not the same as 2D. It's not the same as just the X center.
It's not just the X, although X is part of it. It's the X and Y.
So like,
or more generally, it's the inputs, right? It's what are we allowed to input into this function? Oh, well, the inputs are not just an X coordinate, it's an X and a Y coordinate. So we're asking what are X and Y allowed to go into, and then the range is asking what we get out. So when I'm looking at domain, I'm asking myself, are there any restrictions? Is there anything that X or Y is not allowed to be here?
And then in contrast, looking at range, you just want like the lowest and highest possible value.
Exactly. And usually there aren't anything missing in between. Sometimes there can be. So here the domain is everything. Now be careful. Everything here does not mean all real numbers. That would be what everything is in one dimension. So if you had a function of just X, and like, for example, if I said my function f of X was, I don't know, X squared plus 1, the domain would be all real numbers. But here, the domain is all points in the XY plane. So here the domain is all of the XY plane, which is annoying, but it is what it is. You can also write it as the set containing X comma Y such that, actually you don't even need any such that. There's no restriction such that X and Y are anything you want. X and Y are any real number. Literally every point in the plane. You can also draw it. It's not very fun to draw though, because you're just scribbling. There it is. There's my domain. Everything in the XY plane. Yeah.
by XY plane, meaning like it could be any number where you can make any place where you can make like horizontal functions.
So here's what I would say. So looking at this picture I've drawn over here, again, it looks so nice, and I feel like I'm kind of ruining it a little bit. Okay. So here, let's see if I can do this and not make it look terrible. Try not to like totally destroy the picture here. But there's kind of my XY plane, right? It's the floor. And what we're saying is you can pick any point on the floor. Maybe I want to pick the point over here, I don't know, 7, 7. And that's going to correspond to on the surface, way up here somewhere, if I plug in 7 for X and 7 for Y, I get a value of f of 7, 7 equal to 98. So way up there on my parabola that's opening upwards, eventually I get to that point that's 98 high and has an X input of 7 and a Y input of 7. And also over here at the point where I'm going to say that's X is 7 and Y is -7, you're getting the same value. But in this example, any X, Y are good to go. So we can literally pick just any, make a choice for X, make a choice for Y, put those into the function, and you get something out.
So anything above the X, Y, not below.
Right, this function happens to only have values that are above the X, Y point. That's the output above it. So that actually helps us see what the range is. The range here is all non-negative numbers from 0 to 0. You can get 0 by inputting 0 and 0, and then you can get any positive number you want. Yeah. Well, because all real numbers means that you're only talking about one input. And our inputs are two-dimensional, right? We're inputting an X coordinate and a Y coordinate. And I wouldn't say that the 0.2 comma 3 is a real number, right? The 0.2 comma 3 is a coordinate. It doesn't really have a less descriptive description, right? We have to be saying it's not just a real number, it's a ordered pair of real numbers. So one way people could say it, so I will say there is one kind of shortcut way of saying it, is you could say it's R2, the set of coordinates that are all real numbers in the first coordinate and all real numbers in the second coordinate. That's one way you can't say the entire real number plane. Yeah. If I was doing this on a test, I would, and this was my answer, I would probably just actually write the words all of the X, Y. I feel like that is the most descriptive way of making sure that I'm writing the answer in the way that I know it, and I'm sure the person reading it will know that I meant it. R2 would also be fine, smooth line would also be fine, but I feel like of all of the things I've written there, this is the best way of writing the answer. But they all should be technically correct. Okay. Let's see what else is on my agenda here. Oh, yeah, we should do one of those. Okay. Let's look at one or two more of these, and then we will kind of move on to something else. Sure, let's look at this. Let's look at this pen is not doing it for me. Let's look at the function f of x, y equal to the square root of y minus x over x plus 2. Okay, so let's talk about domain. Got a couple things going on here. First of all, inside the square root, we see that the y minus x has to be greater than or equal to 0. Or solving for y has to be greater than or equal to x. Okay. Excuse me. And then we also see in the denominator that x plus 2 better not equal 0. Or x better not equal negative 2. So this domain is kind of a little complicated to draw. It's not the worst. So let's first talk about what we don't want. Well, we don't want x equal to negative 2. So I'm going to draw a dashed vertical line at negative 2. Don't want you. Okay. I do want the line y equal to x, because I want y to be bigger than or equal to x. I'm definitely going to draw the line y equals x as a solid line. You know, I want to use the same color? Yeah, I guess I do. And then I have to ask myself, do I want the stuff on this side of that line or this side of that line? Well, I'm going to pick a point. Let's pick the point 0, 4. Well, let's pick the point 4, 0. Just to pick one not. So if I pick the point 4, 0, and I try and put it in here, okay, x is 4, y is 0. So if I do that, I get 0 bigger than or equal to 4. I can fly. So this point is not the one. Not it. So that's the wrong side. I don't want this side of that line. I want everything on this side of that line. except for that. I don't want any of that. So there's my domain. It's everything above the line y equals x, but I don't get the little vertical section x equal to -2. Kind of funky. It's especially kind of funky when you start talking about the range. If you were going to write the domain here, you're kind of stuck with the squiggly line. The domain would be the set containing all coordinates x comma y such that y is bigger than or equal to x and x is not equal to -2. There's really no nice way of doing it. You just kind of have to write the things that are need to be satisfied. How about the range? Okay, range. My bet here, although I'm not 100% sure, my bet is that the range is going to be everything. All possible real numbers. But I need to kind of verify that inside my mind. So here's what I'm going to do. I'm going to pick a couple different values for x and see if I can make the outputs be whatever I want. I'm going to try and make it easy. So I'm going to start off by setting x equal to -1, because that's going to make my denominator 1. So I'm going to pick x equal to -1. When I do that, I'm going to have f of -1 comma y equal to the square root of y minus -1 all over 1, which is just the square root of y plus 1. So let me ask you all, when x is -1, what's the smallest output I can get? Well, what can I pick for y that's going to make that small? And I can go a little smaller, but you're close. If I pick y equal to -1, -1 plus 1 is 0. And square root of 0 is 0. So I can definitely get this all the way down to 0. So we can get down to 0. How big does it get? And that's kind of a dumb question because the answer is as big as you want, right? There is no bound. I should really ask, is there a bound on how big? Yeah, right. There's no bound. If you pick bigger and bigger y values, you get bigger and bigger output values. So down to 0 if y equals 1 and as big as we want. Okay. But what about negative numbers? So now I'm going to go back and pick a different value for x. I'm going to pick x equal to -3. Then if I do that, I'm going to have f of -3 comma y equal to the square root of y minus -3. Okay. There's one thing I have to kind of, I just hold on. You guys are like, what are you talking about? There's something I noticed that I didn't account for, which we'll get back to in a second. So here, I can make this as small as possible, again, by letting the insides be 0. So if y equals -3, I can get up to 0, negative numbers. And then if y is as negative as I want it to be, or sorry, not as negative as I want it to be, if y is super duper positive, this whole thing is going to be very, very negative. So this totally gets up to 0 if y equals -3. And then we can get as negatively large as we want by letting y get big. So usually it ends up being that you get everything. That's our range. I can get every positive value by letting x equal -1 and y going from -1 to infinity. I can get every negative value by letting x equal -3 and letting y go from negative. Totally works. So what I'm kind of looking at really is I'm looking right here and saying that's going to give me every, right, this line, letting x equal -1 and y equal anything from -1 upwards, gives me every possible positive output I want. And this line here gives me every possible negative output I want. Kind of neat. I wouldn't worry too much about this, but I kind of got on track of things. But that's what I would say is usually most functions have a little bit more of a well-defined range This one feels kind of weird, like you're kind of doing just a lot of like, well, what if this and what if that? Sometimes that's what you have to do when you have something that isn't enough, like an x squared plus y squared. Questions about what we've done here, or how I justify this to be.
The positive values are going up, but why is the other with the after the negative values also going up?
Well, so here's what I'd say. So this is what's going on. So this, okay, this is where, okay, so this is where I need help from three-dimensional graphing, because it's hard to answer that question without really seeing what's going on here. So let's take a look. Where's the big one? Grab the wrong one. I think that's the one. So if we graph this thing, no, I don't want to do that. Okay. So let's see, we have, yeah, I was having issues earlier today, so hopefully this will work out all right. That's y equal to, yeah, I feel like I'm gonna have problems. Square root of, what I got here, y minus x. Okay, that's all right, and then divided by x plus 2. Oh boy, all right. So here's our surface. It's looking super duper funky. So let's take a look at what we've got here. So this is the positive x-axis here. This is the positive y-axis over here. So x-axis is red, y-axis is green. And let's go ahead and give ourselves two more things here. Let's go ahead and graph the line x, or the plane x equals -1. Hopefully that might help a little. I think I need a different color. So, okay. So, oh man, can we see that? Not super well. I see that. Not super well. So if we look along that plane, you can kind of see that that plane intersects this curve along that line right there, I think. And as we look at that, the function output values are getting larger and larger and larger as we go in the y direction, getting bigger and bigger and bigger. So looking from the top down, oh boy, for a second, right? Here's my x-axis, there's my y-axis. If I let the y values get bigger and bigger and bigger along the line x equals 1, I get increasing values. On the other hand, if I scooch over this vertical asymptote of x equals -2, that's kind of fun. It's just kind of rotate I mean, that's kind of neat. I'm not gonna lie. If we look at x equals -3, turn this one off. Now we see that it's intersecting the surface down below, right? That part of the function has negative outputs, which makes some sense if we think about our function, right? That function up there, square root of y minus x, square roots always spit out positive things. On the other hand, x plus 2, well, if x is bigger than -2, we're going to get positive on the bottom, right? Like if x is -1 or 0 or 1, you have a positive over a positive, so all things positive. So when x was equal to -1, that's why we're getting positive results. On the other hand, if you pick something less than -2, like -3, then you have a positive over a negative. And so the function values are negative. So we're getting out negative results. So that's why over here on this plane, x equals -3, the surface has negative values out there. Hopefully that helps a little bit. I think seeing the graph does help sometimes. Yeah. And then we can kind of justify ourselves that, yeah, we're able to get anything. We can get all the positive real values, all the negative real values. Because that function just keeps going up and up and up, or down and up and down. I could never graph this on my own. Like that, it would just be, that is a surface that is too difficult to graph by hand, for sure. And also, I don't even want to go there. I was going to say the level curves, I'm sure, look really, really funky. So, yeah, so let me just point out, even though I don't really want to, but I think it might be worthwhile. So this function Nah, not y. Trash. Sorry about that. So for this function, if we were going to try and find level curves, here's what you would do. You would set this equal to c. And then you would solve for y. So you're going to get the square root of y minus x equals c times x plus 2. Square both sides. And then to add x. So our level curves should look like parabolas. Do they? Good. I mean, they should. Let's find out. So level curve would be when I break it. Sorry, I broken it. No, I don't want to work anymore. Okay. Fine, be that way. Okay. Sorry, we're almost there. Oops, that's the problem with trying to type on screen, you can't see. So we want, again, the square root of y minus x. Cool. Divided by x plus 2. All right, cool. Good. There it is again. And it's wonderful glory of weirdness. And then if we look at the level curve, like say, z equal to 4. It's not looking very parabolic. We're not seeing enough of it. Oh boy. I don't know. I'm not convinced. It doesn't look like what we think it should look like. What's going on here? There's probably some issue with it being undefined somewhere. So let's actually pick a value. Let's see what happens if we pick c equal to 4, just to satisfy our curiosity. So I've got here, I would have y equal to 16 times x plus 2 squared plus x. And I think the issue here is that you're really only going to get half of it because we have this problem with x equaling -2 being undefined. So there's probably something going on there. So that's why I would say usually we don't look at level curves for trash like this because they just end up looking weird and hard to kind of identify what's going on. All right. So, but there was something else. Oh yeah, I wanted to talk about that. I want to make sure I'm looking at all the kinds of things to think about here. Also, I should point out, reiterate, you're all welcome to ask other questions. Like if there's something like, obviously I've been on a domain and range focused talk today, but if there's something else you want to see, you're welcome to say things like, hey James, what about this or that or whatever. I'm trying to kind of stay in line with what's going on in your homework assignments. But yeah, let's, how much time have I got? Not a lot. Ooh, not a lot really. So yeah, let's go ahead and here's what I want to say. So on class days, Tuesdays and Thursdays, I have office hours after class in C class. No, not C class, CAD, which is the Center for African Diaspora Student Success, which is in the second floor of the silo. The second floor of silo 2, so not in the silo, but the second silo building. Like you guys know where the silo is, kind of like go behind the silo across the little like courtyard area. There's another building, there's like an elevator, you go up and you can go through CADs there. I will be there after class, but it's a bit of a walk. So I feel like I might want to end class a few minutes early so I can get there not super late.